In 2003, the northeastern United States and parts of Canada experienced the third most severe blackout in history. Millions of people were impacted, and the economic loss was estimated to be close to $10 billion. While inaccurate telemetry data, poor communications, and computer glitches destabilized the system, the root cause of the outage was actually excessive conductor sag. A year later, in 2004, CTC Global introduced a high-capacity, low-sag conductor known as ACCC. ACCC leveraged the high-strength, lightweight, and dimensional stability of carbon fiber composites to mitigate conductor sag. During the same time frame, the cost of electricity in the Northeast was at an all-time high. This wasn't due to the high cost of fuel, it was due to grid congestion. Residential, commercial, and industrial consumers paid billions of additional dollars every year for electricity, as the congested grid was unable to allow access to the least expensive and cleanest sources of generation. The ACCC conductor not only offered a means of preventing sag trip outages, it also provided a technology that could be used to eliminate grid congestion, as the ACCC conductor can safely carry twice the current of a conventional ACSR steel-reinforced conductor. In many cases, new lines didn't need to be built because the ACCC conductor could be installed on existing structures without modification. In addition to the ACCC conductor's ability to protect the grid from sag trip outages and eliminate costly grid congestion, the ACCC conductor also offers the lowest electrical resistance of any conductor on the market today. The ACCC conductor's lower resistance translates into reduced line losses. This reduction in line losses typically ranges from 25 to 40% or more, depending upon circuit loading. Reduced line losses not only serves to reduce fuel consumption and associated emissions, it also frees up generation capacity that is otherwise wasted. If we consider a 62-mile line or a 100-kilometer circuit with a load factor of a conservative 53% and a peak load capacity of 1,600 amps, with a typical Drake-sized conductor, the ACCC conductor would reduce line losses by nearly 73,000 megawatt hours every year. If the cost of electricity was only 5 cents per kilowatt hour, this would translate into a savings well over $3.5 million per year, or $70 million during the first 20 years of service. If the generation source happened to be coal-fired, this would equate to a reduction in CO2 emissions of over 250,000 metric tons per year. Considering the typical car in the U.S. emits nearly 5 metric tons of CO2 annually, this would be the equivalent savings of taking nearly 53,000 cars off the road. In this scenario, the reduction in line losses would also free up 29 megawatts of generation capacity. To put this in perspective, the cost of reconductoring a 62-mile line with ACCC conductor would be about $7 million. Approximately half this cost is the conductor cost, the other half is installation and hardware cost. With line losses reductions alone at 5 cents per kilowatt hour, the project would pay for itself in the first 2 years. And the benefit over the following 18 years, the savings would be about $63 million. This doesn't take into account the additional earnings that could potentially be realized for delivering up to twice the power. Additionally, as the installation of the ACCC conductor would free up nearly 29 megawatts of generation, the $7 million initial investment saved $29 million in generation. While utilities worldwide have spent billions of dollars improving the efficiency of generation to reduce operating costs and manage fluctuating fuel prices, and spent billions more supporting the deployment of more efficient demand-side appliances to defer new generation investment, improving the efficiency of the grid itself has not been a primary focus in the past. In the U.S., this is primarily due to the fact that we only lose about 6% of all electricity generated to T&D losses, and the costs are simply passed through to the consumer. While 6% seems like a rather small number, it's actually a very big number when you consider how much energy we actually consume every year. Worldwide, that's roughly 20 trillion megawatt hours. In countries such as India, where T&D losses are well over 20%, the problem is obviously much more severe. In any case, as efforts move forward to improve the efficiency, capacity, and reliability of the grid, in parallel with reducing emissions associated with climate change, our regulators, grid operators, generation companies, and transcos all need to work together to leverage technology as it becomes available. With the installation experience of well over 30,000 kilometers of ACCC conductor at over 350 project sites in more than 30 countries, CTC Global can help you leverage technology to power your world. Thank you.